So we are reviewing mathematics. The topic we're going to look at for now will be calculus. So we are going to use the power rule and the chain rule to differentiate some of the functions here. But basics before we go into differentiation will be as follows. Whenever we're differentiating variables for an equation y is equal to a x to the power n, this will be dy over dx, where we're going to multiply the power by the coefficient. So this will be na. Then we subtract 1 from the power, which is n minus 1. So this is how the differential moves. So for a variable like 6x to the power 5, this will be dy over dx. And we're going to multiply the numbers there, 5 by 6, which is 30, and subtract 1 from the power, which is 4. So this is what we call the power rule. Now this power rule can also expand if you're given u is equal to 6x power 5 y to the power 3. There are two letters, or rather 3. So we're going to differentiate implicitly. So this is du over dx. So the letter that we are going to maintain is a y, because that's not what we're differentiating. So we're going to differentiate 6x5. When you differentiate it, we're going to get a 30x to the power 4. Then we also do another differential of du against dy. In this case, we're going to leave our x to the power 5 alone as a dummy. Then we're going to concentrate on these two letters here, 6y to the power 3. So 3 times 6 is 18. Then we subtract 1 from the 3 to get a what? A 2. So this is what we call implicit differentiation. So when dealing with implicit differentiation, sometimes the figures will be given will be a function like this. So here, this is dz against what? Dx. So only where there's x are we going to differentiate. If there's no x, we'll consider it as a constant. So differentiating this will be 18x to the power 2. Then in this case, our dummy is y. We're not interested in the y, so leave y as it is, don't touch it. Then we differentiate 6x3. In its derivative, we're going to get what? 18x what? 2. Then the latter part here doesn't have an x. It will fall out as a constant. So we can now go to differentiating dz against dy. So here, do we have a y? No. Here, do we have a y? Yes. So this x will only survive on the assumption that it is multiplying. So x3, we'll leave it as it is. So we're going to remain with minus 6y7. So multiply 7 times 6 is 42, minus 42. Then what do we do to the y? The y there, we're going to subtract. So we're going to get a 6. Then here, do we have a y? Yes. When differentiate this, we're going to get minus 24y3. So these are called partial derivatives. So I want you to try with me. Suppose you're given q is equal to 10 L to the power 4, k to the power 8. So can you do dq over dl? What do we have? Which one is our dummy?
N.
Our dummy is k8, right? We leave it as it is. So what are we differentiating?
L to the power 4.
10L4. So what is the derivative of 10L4?
40L to the power 3.
40 L3, correct. And if we're differentiating the Q with respect to K, which one is our dummy?
10 L to the power 4.
L4. So what do we remain with? 10K8. So you just remove the letter, not with the number, because this number is for both of them. So L4, we'll bring it back. So we're going to remain with 10L8. So what is the derivative of 10L8?
80 to the power 80K to the power 7.
80K7, correct. So this is implicit differentiation with what? With partial derivatives. Sometimes we may have a chain rule. This chain rule is based on the pretext that we have something to the power. So when you differentiate, you differentiate what is, you drop the power here, then differentiate what is inside here, then leave what is inside as it is, then subtract 1 from the power there. So if you have y is equal to 4x to the power 3 minus 5 to the power 2 to the power 3. So dy dx in this case will be, differentiate what is inside here. This is 2 of what? X to the power 2.
Okay.
Times, you multiply the power here, it comes down there, times 3. Then leave what is inside as it is. 4x 3 minus 5. Then subtract 1 from this power there, which is a 2. The final answer of what? It is 6x 2, 4x 3 minus 5 to the power 2. All right, let's try it again. If you have y is equal to 10 minus x4 to the power 7. So what we do, dy over dx, you can drop the 7 if you want, times, you differentiate what is inside here, is negative 4x3. And you write what is inside there, which is 10 minus x4 to the power 7 minus 1, which is 6. So you evaluate now. So this is minus 28 x3, and this 10 minus x4 to the power 6. So this is what we call a chain rule. Okay, try of y is equal to 10 plus 3x to the power 5 then to the power 6 outside there. So what do we do? dy over the x, what do we drop first? We drop the 6. Then differentiate what is inside, 15x4. Then rewrite what is inside, 10 plus 3x5. Then subtract to the power minus 1, which is the 5 there. Then evaluate. And evaluate, we get 90 x4, 10 plus 3x5 to the power 5. Are we together?
Yes.
So this is what we call the chain rule. We also have what we call the quotient rule. Quotient rule, if you're given y, is equal to a over b. So to differentiate, whenever I say differentiate, I just put an apostrophe. So we differentiate a, we multiply by b as it is, then you differentiate b, multiply by a as it is, then you power the base. So in the case where you have t squared 1 minus 2t. So this is dy over dt. So we differentiate the top guy. What is t squared? It is 2t, right? According to this format.
Yes.
Then we apply it with what is down as it is, 1 minus 2t. Don't do anything. Then since we're dividing, the division goes into subtraction, so we subtract. Then we start from down there. Differentiate what is down, we're going to get what? Negative 2. You multiply it what is down on top as it is, t squared, over, you square what is down there, 1 minus 2t power 2. All right.
I'm a bit lost.
I repeat, you differentiate the numerator and multiply by the denominator as it is. So when you differentiate this numerator, t squared, it is 2t, times, you multiply by the denominator as it is, 1 minus 2t. All right, together, this is the first part here. All right? Minus, you just start now from down. Differentiate the denominator. 1 minus 2t, we will get negative 2. That's a negative 2 here. Then you multiply the derivative of this one times the numerator as it is, t squared. All right, so this is what we did here. Then you just square the denominator to the power 2, which is this part there. So what you end up having is, expand there, it is 2t minus 4t squared plus 2t squared over 1 minus 2t to the power 2. So these are like terms. The final answer is what? 2t minus 2t squared over 1 minus 2t to the power 2. If you want, you can simplify it. We factor out a what? A 2. So here, a 2t. You're going to have 1 minus what? T. Then here to be 1 minus 2t squared. All right. Are you still lost?
Yes.
I explain again. Okay. So what we are saying is, when you're differentiating, the rule is simply make a simple formula there. Differentiate the numerator times the denominator as it is, minus differentiate the denominator times the numerator as it is. Then you power the denominator. So in this case, we differentiated the numerator, which is 2t squared. When differentiated, it is 2t, times the denominator is 1 minus 2t as it is. Are we clear on this part?
Yes.
Then minus, since the quotient rule, we subtract, we start from down. Differentiate the denominator, 1 minus 2t, it is negative 2. You understand where the negative 2 is coming from?
Yes.
It's a constant, this is negative 2, so negative 2, times the numerator as it is, the 2t squared, which is that one. All right? Over the denominator squared, so 1 minus 2t, we square this part. So what remains just expanding? 2t times 1 is 2t. 2t times 2t is negative 4t squared. Then minus 2 is positive. Then 2t squared. Then here we square that. So this is where we're ending. But you can simplify these two, minus 4t plus 2t squared. This gives us minus 2t. So you can get your full marks there, or just simplify it here if you want to go further. So let's try if we had 1 minus x over x squared plus 1. Let's do this together. dy over dx. So what are we doing first? We differentiate the top part. What do we get when we differentiate the top part? Minus 1, right? Then you multiply it with the bottom part as it is. What do we get? X squared plus 1. Then
subtract the denominator.
so you differentiate the top part, -1, times the bottom part as it is, which is this part, minus, we differentiate the bottom part, it's 2x, times the top part as it is, 1 minus x. Then you square the bottom part. Are you seeing this?
Yes.
Then you expand, -x squared. Okay. Then what are we getting?
-1. -2x plus 2x squared. Three x.
So minus x squared plus x squared is what? It's plus x squared. This -1 minus 2x will remain as it is. All right.
Yes.
That's how it remains like that. Interesting, isn't it? So sometimes they will now combine the quotient rule. Okay, so to say x squared minus 1 to the power what? 5 over 2x minus 3. So what is the y over the x? Let's now differentiate the top part and differentiate it. What do we get? Drop the 5, then differentiate what is inside 2x. So get what? 10x. Then we subtract, write what is inside there, subtract the 1 to get a 4. So we differentiated the top part. You multiply it with what is down as it is, x minus 3. Then we go to minus, differentiate what is down, is 2, times what is on top as it is, x squared minus 1 to the power 5. Then what is down, you square it to x minus 3 to the power 2. I repeat, this part here, I was just using the rule. We drop the 5, then differentiate x squared with what? 2x. And write what is inside there, x squared minus 1. Subtract 1 from the power there we have a 4. So 2 times that one, what we get? 10x. Then here what we have? X squared minus 1 to the power 4. So this is what we have here. You get it? That is just on differentiating.
Yes.
All right. Then 2x minus 3, which is the bottom guy here. 2x minus 3. Then minus, we now start differentiating. This part, when differentiated, 2x, it will be 2. Then what is on top as it is? X squared minus 1 to the power 5. And squared it. At this point, you get your full marks as you get. Now, you can't expand this because there's a power there. So this can be expanded with that one. So here we're going to have what? 10x times 2x, this is what? So we're going to have what? 10x times, that is 20 what? X squared. Then 10x times that one, what we get? 30x. Then this one will remain as it is, x squared minus 1 to the power 4. Then this also can't expand itself, we'll leave it as it is, x squared minus 1 to the power 5. Then leave what is down as it is, to x squared minus 3. to the power 2. So it is an integration of rules that you need to apply, and you need to apply them very well. Are we together? Any questions so far?
No.
All right. Well, I must admit that your papers are not easy. This is engineering math, literally. So it takes a lot of practice understanding the concepts that are in here. All right, so let's look at some of the questions from the exam paper where you're required to differentiate. So we'll look at some questions from here. So differentiation. And the value of dy dx. Okay. So we're given the following functions. Let's try to look at this function here. Y, when you're given f of x is as good as putting y there. So given y is equal to a third of x to the power 3. Then minus 2x squared plus 3x. Kindly help me differentiate this. Let's differentiate this function. dy over dx. What do we get? A third of 3 is just 1. We never write 1. That one from that one, we get a what? A 2. Then here, we get 4x. And here, let's differentiate here, we get what? Positive 3. This is a derivative. Okay. Then we've been asked to calculate the stationary points. So although that's another lesson for another day, but I just needed you to understand that firstly, you need to differentiate here, then equate to 0. And this becomes a quadratic equation. So you need to solve for what? You need to solve for the value of x. All right. Any questions so far? Any questions so far?
No.